Little update on Malaysia Airlines Flight 370, the missing plane, the mysterious missing plane that has been missing for so long now. You really don't hear about this plane anymore. It's not in the news anywhere. And you just don't see any more information on this plane. And the reason for that is because of all the actions taken to find this plane, find any piece of evidence as to what has happened to Flight 370. Everything has failed. There is no evidence. We don't have a clue where this plane is. The only evidence we have is it disappeared off of the map. Just suddenly disappeared off the map. And call it a mystery if you will, because that is indeed what it is a mystery at this point. Nobody knows what's happening. But it's very serious as to what could have possibly happened to this plane. Every action that has been taken on searching for this plane has turned out absolutely no evidence. All the pieces that were supposedly floating around in the ocean, in the Indian Ocean, nothing there. The pings that they thought they heard, that they thought maybe was from Flight 370, was not from Flight 370. This has been revealed here recently. So the current news is a recorded noise might offer some clues to the missing plane. A recorded noise now. So now they have a noise that was recorded of possibly this airplane crashing into the ocean. The sound of the plane crashing into the ocean. This is just a possibility. And this is coming from the New York Times. Scientists plan to release detailed information on Wednesday about a mysterious noise, possibly that of an ocean impact recorded by two undersea receivers in the Indian Ocean about the time that Malaysian Airlines Flight 370 ceased satellite transmissions and vanished on March 8th. The low-frequency noise, which was outside the normal range of hearing and had to be sped up to be made audible, appears to have been traveling halfway across the Indian Ocean to the receivers off the coast of Australia. It's not even really a thump sound of a noise. It's more of a dual oomph, said Alec Duncan, a senior marine science research fellow at Curtin University near Perth, who has led the research. The general vicinity from which the noise emanated is a large area of the central Indian Ocean off the southern tip of India and about 3,000 miles northwest of Australia. But that is not consistent with calculations of an arc of possible locations in the southeastern Indian Ocean where the plane carrying 239 people might have run out of fuel. Those calculations were from Inmarsat, the global satellite communications company. Scientists have struggled to figure out the origin of the noise. Dr. Duncan also says, if you ask me what's the probability this is related to the flight without the satellite data, it's 25 or 30%. But that's certainly worth taking a very close look at. A deep-sea submersible searched without success this spring in a very small section of the arc indicated by the satellite data. This was about 600 miles, or about 1,000 kilometers, off the Australian coast. Even without the Inmarsat data, there are other possible explanations for the noise besides an aircraft impact, Dr. Duncan said. One would be a very small undersea earthquake that would produce a similar noise audible across great distances, but not strong enough to show up on the nearest seismometers on land, which did not record a tremor at the time. The direction from which the noise arrived does produce some small earthquakes every year, although there had not been one in the days preceding Flight 370's disappearance, Dr. Duncan added. Now there are two receivers, one operated by Dr. Duncan's team and the other by the Comprehensive Nuclear Test Ban Treaty Organization in Vienna, produced enough data to establish the direction from which the noise arrived. But the distance to the source of the noise was less clear. The result, according to Dr. Duncan, is a box of ocean several hundred kilometers wide but a couple of thousand kilometers long, Dr. Duncan said. That would be an area roughly the size of Texas. Mark Pryor, an acoustics expert at the Test Ban Organization headquarters, said that the sound might be consistent with an impact or with some kind of sealed air-filled container that sank into the depths until the exterior water pressure caused it to crumple. Mr. Pryor said that the sound might have been reflected off a seamount or underwater mountain before it traveled to the two receivers. So the receiver's data might be indicating the distance and direction of the seamount, not the origin of the noise. The Australian government has funded the research at Curtin University, and additional experts at Canberra, the country's capital, have also collaborated. The Australian authorities have been skeptical so far about ordering a new search thousands of miles away based on that noise. Martin Dolan, the chief commissioner of the Australian Transport Safety Bureau, said last week that the search operations would continue to focus on the narrow arc defined by the Inmarsat calculations. Dr. Duncan and his team operate an undersea device off the coast of Perth that is mainly used to monitor the low-frequency cries of blue whales, the world's largest mammals and one of its most endangered species. The team's receiver or hydrophone records noises on an undersea data device which is hauled up to the ocean's surface every 6 months and its contents downloaded. The team sailed out for an extra visit to pull up the recorder and recover the data after the search for Flight 370 shifted to the Indian Ocean. The noise was faint but detectable, prompted Dr. Duncan to request and obtain the Test Ban Treaty Organization's data for March 8th from its receiver off Cape Leeuwin, 220 miles to the south. The organization did not initially detect any noise, Mr. Pryor said, because it was using a high threshold for confirming a noise based on its experience with underwater explosions. The organization has since rechecked the records of its other operating hydrophone in the Indian Ocean near Diego Garcia, but the noise was not detected there. Its undersea receivers continuously relay data by cable to shore, where it is uploaded by satellite to Vienna. Noises travel through the water at a speed of 1.5 kilometers per second, or almost a mile per second. That is 5 times faster than they travel through the air, and there is less attenuation of the sound over very long distances through the water as well. Mr. Pryor and Dr. Duncan said in separate telephone interviews that the time it took for the noise to reach the receivers was consistent with the last partial electronic handshake between the missing Boeing 777-200 and the Inmarsat satellite, plus the time it would have taken for the sound to have traveled several thousands of miles to the hydrophones. So that is the update on missing Malaysia Airline Flight 370.